have invited Mr. MD Naimur Rahman. Paper ID 74, Smart Water Quality Monitoring System based on Internet of Things, IOT. So maybe it will also be related to previous paper. Please present your research work.
Okay, thank you, Mr. Chair, Co-Chair, and distinguished audience here. I welcome all to my presentation. Actually, I will present on behalf of my research group here, and it's a simple work to me, as it is done by one of my third semester student. The presentation title is a Smart Water Quality Monitoring System using Internet of Things, or based on Internet of Things. Here is the outline of my presentation. As you know, the water is the basic need for human survival or for industrial use. And we know due to increased industrial output or use of fertilizer, the water quality is deteriorated day by day. And for our health issue or for our industrial purpose, we need quality water, and we need to monitor, or we need to determine the quality water. As you know, the traditional water quality monitoring or testing is time consuming and costly, because we have to carry out the water from the specific sample to the lab, or then we have to determine the quality using the testing device. But if we use Internet of Things along with some sensors that we really use for Internet of Things architecture, then it will be very simple and cost effective. This research introduced the development of a low-cost IoT-based smart water quality monitoring system for measuring the physiochemical water parameters, and which enable real-time monitoring and testing. And here in this research, we use temperature sensor, TDS sensor, turbidity sensor, and pH meter, and also for flow sensor for measuring the flow of the water. Here is the existing work that have been performed earlier. Here is the flow chart for our total research work. This is the system architecture of our research, and it is very simple, as we know that we have used different sensors, that pH sensor, temperature sensor, turbidity sensor, TDS sensor, and water flow sensor. Then the phase data sent to the microcontroller, that is Arduino Mega, and the data will be then sent to the cloud server, and then we have found the phase data in developed web page. Here is the collecting of sensor data flow diagram, and our system prototype is here. Here is the experimental result. Here we have found in our developed web server. Here we know the temperature is a important factor for water, and the normal temperature range is 5 degrees Celsius to 26 degrees Celsius. And our system find the sample water temperature is in between 22 to 23. Here we have taken 100 sample of data. Then pH sensor define the pH of the sample data. As we know, this water can be acidic or alkaline. We know the pH, normal pH range is 1 to 14. If it is less than 7, then it is acidic, and higher than 7 it is alkaline. And we have found this water sample pH range is 8 to 9. And then TDS, it measured from this TDS sensor, and we know that total dissolved solid, that means the cleanliness of the water is determined by the TDS meter. And here we know that if the water is less than 300 ppm, then it is excellent quality of water. And if it is more than 1200 ppm, then it is not acceptable. The sample water we have found, the range, TDS range is 525 to 545 ppm. Then electrical conductivity is related to TDS. That means the conductivity is water, pure water do not conduct any electricity. It is depend on the dissolved salt or dissolved solid. And the electrical conductivity we have found by the TDS value. We have divided the TDS value by a conversion factor, and we have taken the conversion factor 0.5 here. Then we have again the water flow sensor to find the flow of the water, and here the water flow is determined as liter per minute, and here we have the water flow ranges from 0 to 0.5 liter per minute. And then we have used the turbidity meter, and we know that the turbidity and voltage has a common relation here, and the turbidity is ranges from 0 to 3000, and we have found this turbidity is range is 500 to 3000 here. In conclusion, IoT device have been deployed and efficiently monitor and collect the data from the server. Different sensors like water flow, turbidity, TDS, pH, temperature sensor are used for quality monitoring, water quality monitoring. And microcontroller device access the information which is monitored by the users of sensors. And the real-time values are different water parameters as accessed through the smart water quality monitoring system. Thank you. As I said, that it is a simple work of my third semester student. I expect suggestions so that he can do better in future. Thank you.
Thank you, Mr. Naimur Rahman. He is an associate professor in the Patuakhali Science and Technology University. So this is a real research work. Just I want to know again how IoT calculate this data.
Actually, IoT cannot calculate that. We can find here from using the sensor here. We use pH sensor, TDS sensor,
Just
temperature
please
sensor.
show in your system. Yes.
Actually, we just
how water quality is measured by this system. Is it
okay? We use different sensor. Water. Actually, water pH sensor, water TDS sensor here, and connecting Arduino. Then we use this sensor in water, and the sensor give the data here.
Okay, all sensors are inside this system.
All sensors are integrated. Integrated.
You have collected data inside this. The water.
Okay, here
inside in the pot.
Here is
not in the flow line.
Here is the roll here, or has the port. We can supply the water here, and we found this water flow through this through this pipe using this sensor. Use Hall effect here. So we use this pipe only for water flow, and other sensors are integrated through this Arduino, and these sensors collect the data.
Okay, I can understand now.
Actually,
referring the data for pH and TDS. Gofur sir find out the question already, what I wanted to ask you. And actually no more question. And thank you for your nice presentation. And all the presentations has been completed, sir. So now we can conclude our presentation session. So, sir, we'll conclude this.